When we get into the Jupyter Lab page, this is the landing page you will see at the beginning. You can see two panels here. One on the left, it is the file browser you will see later when we pop up files in this panel. And then on the right side is the launcher where you can launch many options. For now, we will start with this terminal. Let's switch to the bash. So now let's get to the GitHub page where we can see the instructions at the beginning. First, we need to clone this repository. That it means that we download all the codes to our SageMaker instance. So here are the instructions. We just copy them there. Start from change direction to SageMaker. This is actually the file. This is actually the directory corresponding to the file browser we're looking at right now. It is now empty. And then we clone. You can see now it's downloading from the GitHub. And then now it pops up here. We can also do the same thing, try to change directly to it. Now you are ready to go on all of the codes, notebooks, and libraries. It's all in here. So the first thing we do is to create a Conda environment. And we'll talk about the Conda and environment and how to use SageMaker on this using a lot of Python libraries later. For now, let's just start running. The command is basically telling it to create an environment called tutorial env. It will take a while, probably 10 to 15 minutes, and most of the time it's shorter than that. We can now switch to the slides. While we're waiting, I want to give you some background information on this work we present. The big picture of our work is that we combine the satellite image and LIDAR data and then input them into a deep learning model on SageMaker, the Amazon SageMaker machine learning service, to predict a road network or building footprints. These map features can be extracted from those image features. Speed-wise, we can achieve about 10 kilometer square per minute inference speed. It means that we can process this much area in 1 minute on a P3 8 times large instance. It contains 4 times V100 GPUs, which is quite powerful, and you don't have to worry about the installation, say all kinds of CUDA libraries, of Python libraries. The SageMaker instance already have those things. And a glance at the results that we want to show today is to highlight that the baseline without LiDAR data, if we only use the satellite images, is going to be really high. But if we combine the two together, if we combine the RGB and LiDAR data together, we can achieve even higher than some of the winning teams at the original contest. And so this is some exciting thing. And then do notice that even though if we only use LiDAR data in the prediction, it's still going to produce some comparable results. So we use both LiDAR data and RGB to prove that we can use either one of them, or if we want to improve the result, you can combine the two together. That's a good news because sometimes you can have RGB image, sometimes you can have LiDAR data, and then those two sources can be separate, they can be independent. You can just choose whichever you want or whichever you have to train a model in your area of interest, or you can combine both if you actually happen to have both of them. So that's the perfect purpose of showing this idea to you. And then we pulled all data from AWS Open Data Registry. So this is an initiative program by AWS and all the data providers. You can go to this website and then check out. There are many data sets available. So just to mention geospatial dataset domain, not only we have a SpaceNet, USGS LiDAR, we also have other satellite images or geospatial data available, such as Sentinel or other kinds of things. And you can find some more in other domains, such as medical domain, vertical domain, or vice versa, you name it. So the first data set we're going to use today is the SpaceNet satellite imagery. It contains over 27,000 kilometers square of very high resolution imagery. That's a large area. In total, there are 811,000 building footprints and about 20,000 kilometers of road labels to ensure that there is adequate data available for geospatial machine learning research. So for machine learning research, not only need the images, we also need high quality labels to train a model to do something. We know that we all have access to various resources of imagery, but SpaceNet is one of the one of the few image providers who also give you the annotation labels. So take Las Vegas for example. The images in this area of interest cover 216 kilometer square area, including 151,367 buildings polygon labels and 3,685 kilometer of road labels. So that's a lot of information you have in this area. And I'll just give you a feeling of what these data look like. They come with 0.3 resolution, pen sharpened RGB image, and are cropped to tiles with 2 different sizes. For building detection task, for example, in this image, it's going to be 200 meters by 200 meters. And for road detections, it's going to be zoomed out 2 times, is 400 by 400 meters. All data are hosted on AWS3. So you will see in the next step how we download this quickly just from one line, one command line in the SageMaker. It's going to be really fast, although the data is huge. It takes about 5 minutes to complete. So it's fitting well into our tutorial. We don't have to worry about the time to download the data. Another data set we are going to use today is the USGS 3D LIDAR data. So this program is to complete the acquisition of nationwide LIDAR to provide the first ever national baseline of consistent high-resolution topographic elevation data, and collect it in a time frame less than a decade. So we can expect that most of the data are available, or they are collected within a decade, not much change in between. And currently there are over 1.77 million these last tiles format compressed using the last zip compression encoding in these US West 2 region. This is the region code for AWS resources. There are over 12 trillion LiDAR data point available from over 1,254 projects across the US. If you go to this website, and you can see a lot of areas are covered. For example, you can see from this map here. And the reason why we chose Las Vegas as our area of interest for this tutorial example is that we actually have both SpaceNet and LiDAR data available in this city. And in many areas, they actually overlap. So that's really fortunate to have some situations here. But most of the time, you probably have one source and another one not available. Our experiment actually shows that with LiDAR data, you can achieve similar accuracy as using satellite. So these two can be interchangeable if you want to extract map features from the imageries. And then in Las Vegas itself, we have over 600 gigabytes of 3D point cloud data here. So this is a bird view of it. We can even go down to see. So this is a view I believe many people are familiar with, this hotel. Probably some of you even lived in this place, the little Eiffel Tower replica in the Las Vegas. If you go down to the data visualization tool in this website, you can see things like this. And then actually we can go there and then take a look, tour around. Right now we're in this Pochi viewer, the visualization of 3D LiDAR points. I'm wondering, and if you can tell where I'm looking at. So let me just zoom into this. All right, so this is downtown Austin where I live at. And this is the UT campus I'm proud of. I graduated from UT just in May this year. Hook 'em horns, and if you are also a Longhorn, this is the UT Tower. Let's get back to the installation page. You can see that we already successfully installed everything in that environment, and we can verify in this way. Just open the launch page. Now you can see we have a new environment kernel called Conda tutorial M. If we click this, this will create an untitled new notebook for us with this kernel. So to verify that, we can import one of the libraries we just installed. For example, here, albumentations, Augmentation is a great library to do data augmentation for machine learning training. You will see that really a lot if you are familiar with deep learning. So you can see now we successfully installed this just to make sure. Check out the version of it. 0.4.3 is the same here. So that means that we already had everything listed down here. All right. Check out the next step. The next step is to download from the S3 buckets. We can download necessary files from S3 bucket prepared for this tutorial, and just by running this command here. And then we'll download about 23 gigabytes of things, including intermediate data and trained models for you to reproduce the deep learning training. So while we're waiting for it, let's show you what we have been doing for this intermediate data and then why we are saving them so that you can run from this stage.